not the same thing, like even remotely. Greetings, welcome to yet another episode of Astronomy 101, because apparently I'm qualified to talk about that. Last video did very good. I'm very proud of it, but today's topic of discussion is going to be about black holes, and I think that's a very interesting thing to talk about, because it kind of ties into what we were talking about yesterday, with how, like, you know, you have like the planet and you have the star, and it talks about the star, or how the planet goes around the star, and it's like really cool. It's fucking freezing in here, by the way. It's really cold. I'm sorry if I'm shaking. It's really cold. So if we think about black holes, right? Most people are thinking that, oh, you know, you got a black hole, right? And its main goal is to suck everything up, right? Well, that's only partially true, right? So essentially, a black hole is it's a void. Like, you can't see it, right? Because, like, there's no light that could pass through it, and that's what makes it look black, right? So when you see it, it like curves light going into it, right? So if you were to look at a picture of a black hole, it would just be darkness, but around it, it would be like you have like a swirl effect, right? It would be like a little swirly thing, and that's because it's like warping all the light around it, so it's blending light around it. There's a lot we don't know about black holes. Some people believe in spaghettification when you go through it, which is basically you get stretched so thin you turn into like spaghetti. I don't know if that's been proven. It could be proven. I'm not sure, because, I mean, like I said, I just took a course of astrology in high school, which isn't astronomy, by the way. But regardless, you know, I kind of have an idea here, right? So it's you know, you go into the black hole. You go in like this, and you come out like that, like it just, you get crushed, basically. You get crushed because they're so massive, right? So like a black hole is formed when like a star dies, right? So it's like you got a star, and it grows and it grows and it grows, and then it gets super big, and then once it's like reaching the end of its lifetime, it's like, what am I gonna do now? It just fucking collapses in on itself, and then it just, then you got like this is a real thing, by the way. When a star dies, if it's big enough, it'll like go. I forgot what they're called, but it's like the star will implode on itself, and then it'll just explode, right? And this will like destroy entire solar systems that are near it, okay? This is real. Like, at any moment, we could just be chilling, and then next thing you know, we'd be looking in the sky like, oh shit, and then boom, we're all dead. And it's not even because of our star, it's because of a star from like 2 or 3 solar systems away. Yeah, you know how you look up at night and you look at the stars, count your fucking days, because one of these days those stars are gonna kill you. Food for thought, okay? It's terrifying just to think about. So what's left over after the star dies, right? Well, that's where you have the black hole, right? You have the black hole, and the black hole is basically just a bunch of mass, right? And it has, I think it's got like the same amount of gravity or some shit like that as the star. Basically, to put into perspective, if we're talking about a black hole in terms of mass, and this is the thing that I want to primarily talk about, because I think that this is actually really interesting, right? So it's like, you have the super massive little black hole, right? And if you were to say replace our star with a black hole of equal mass, right? So you take our star, our sun, you get rid of it, and you just swap it out with a black hole of an exact same mass, right? This is the cool thing. This is where things get really like mind-blowing here, okay? So you got the black hole, and it's got the same mass as our star, but our star is gone now, right? How do you think that's going to affect all the planets around it, right? Do you think they're still going to revolve around the black hole the same way they did around the sun? Fun fact, they are. As a matter of fact, there's not going to be a single shift in their revolution around the black hole, right? It's going to be as if nothing ever changed, aside from obviously, all life would die out and everyone would freeze, right? But their orbit would remain the exact same, right? So if we're thinking about this in terms of scale, right? Let's go ahead and start small, and then we'll work our way up and get bigger of this comparison, right? So the same way a moon will revolve around a planet will revolve around the sun, right? Or around a star. But here's something interesting. What does the star revolve around, right? You're thinking, okay, well, there's multiple different kinds of stars. You got rogue stars, but they all have to be tethered to some kind of gravity, right? Well, what are stars a part of? They're parts of galaxies. What is at the middle of a galaxy? I wonder. Well, if you were to look at a picture of, say, the Milky Way or the Andromeda system or any known galaxy, you look at the center, right? And you see a massive ball of light, and you're thinking, well, that's gotta be just like a massive star, right? No, here's a really cool thing. Those are supermassive black holes, right? Those are black holes at the center of the galaxy. The question is, why are they super bright, right? Well, here's the answer. So there's a lot of stars that get close enough to the black hole that they're revolving around the black hole, but they're going super duper fast around the black hole, right? They're just close enough not to get sucked in. They're on that border, right? And they're just going like this around the black hole, right? So remember how we said that a black hole warps light around it, right? So it takes all the light from the stars that are close enough to it and it warps them. And that's what creates that massive star-like looking thing, right? Isn't that just amazing? Like, think of it. It's like you got the black hole, and then it just like all the stars in the middle of the black hole, and they're just going like. Am I the only one who thinks that that's fucking interesting? Am I the only one? Am I like I can't be crazy here. I can't. I don't. It's cool. Can we just acknowledge that it's cool, please? That at the center of every galaxy is a fucking black hole, and everyone's just thinking that black holes do nothing but like suck shit up, Sure, like if so to those of you who think that all a black hole does is suck things up and that's why you don't want to get too close to a black hole, I raise this question to you. If you were to get close to Jupiter and close enough to get affected by Jupiter's gravity, right? You're gonna get pulled into Jupiter because of its gravity, right? So essentially it's the same concept of the black hole. If you get close enough to the black hole, you're gonna get sucked up by its gravity. Let's also take this another step, right? If you get too close to the sun, well, first of all, you'll die because you'll burn, right? But after that, you'll probably get caught in the sun's gravitational pull before you get burnt up. As a matter of fact, technically we already are in the sun's gravitational pull because we're fucking revolving around the sun right now, okay? So you shouldn't be that afraid of black holes because their goal isn't to suck shit up. They're basically just voids of mass, right? There's mass and gravity, and that's it. That's a black hole for you, all right? So basically, a star is to a planet what a black hole is to a star, right? So it's like you have planets going around the stars, and you have the stars going around the black hole in this galaxy, and that blew my mind. So that was today's topic of discussion, black holes. I hope you learned something interesting. I'm being told that we are introducing a new segment to this series called where I answer questions that were left in the comments of the previous episode. So if we have any comments, I'd like to read them now. Oh, what's that? Oh, there weren't any comments? Stay tuned next time where we talk about the equation for discovery of life. Seriously, fucking astronomy?
Well, they're both from space, so I thought they were the same.
No, it's not the same.
You're mean.
It's not the same at all.
Has anyone ever told you that? You're mean.